All right, today we are going to be talking about simplifying square roots and rationalizing the denominator. So remember, perfect squares are numbers that you can take the square root of and get a whole number answer. So we'll list a couple of them here. All of these numbers, if you take the square root of in your calculator, you will get an answer that is not a decimal. Whereas if I took the square root of, let's say, 115, you're going to get a decimal. You'll get something maybe around 10.6, 10.5. But all of these numbers are perfect squares. And let's do, yes, I think that's as far as I want to go. Now, the math definition for all this, a number R is a perfect square of a number S if we can say that R squared is equal to S. Like I said, that's the math definition. You can just realize that perfect square is if we take the square root of a number, we need a whole number answer, no decimal. This is an example of a radical. The square root of S would be that. Square root this symbol right here is a radical sign, and there are more roots than the square root. We have third roots, fourth roots, eighth roots, and so on, and they all use the same symbol, but they'll have numbers written here, like that would be the third root. If you don't see a number there, then it's just a square root. The stuff inside the radical sign, beneath or inside, that is called the radicand. Again, it's another fancy math word. I'll most likely just say stuff inside the square root. Now, to simplify a square root expression, so a square root expression is simplified if the following are true. No perfect squares other than 1 are in the radicand or under the square root, and no radical appears in the denominator of a fraction. So that's like proper grammar that we have. We also have proper math, and proper math is to not have a square root or any radical in the denominator. The most common thing we're going to be using is called the product property of square roots. And what that says is that if I have inside a square root two numbers being multiplied, I can break that up into two separate radicals, two separate square roots, and have the numbers there on their own. And we can go in the other direction. If I have two separate square roots, I could multiply the two numbers and put them under one square root. So if we have the square root of 98 right here, what we want to do to simplify this is to break this up into two perfect squares. Sorry, two factors, where one of those factors is one of the perfect squares from up here. So I get out my calculator and I start dividing 98 by these numbers until I get a whole number answer. 49 and 2. Those two numbers multiply to 98, and 49 is a perfect square. So I'll go ahead and take the square root of 49, and that gives me 7. And then I'll bring this down as a square root of 2. And then I will look and see, can I simplify this any further? Can I break down the square root of 2? And you can't. So this would be our final answer. So we always want to break up our square roots, our radicals, into two factors, and one of those factors is a perfect square. We want to find the biggest perfect square. So 48, we can break up 48 to 16 times 3. The square root of 16 is 4. So this is going to be 4. And then we can bring this down times the square root of 3. We can't simplify the square root of 3 any further. So that is our answer. Break up the square root of 80. We can break this up to 16 and 5. 16 times 5 is 80. The square root of 16, again, is 4. The square root of 5 is just 5, and we can't simplify that, so we are done. One of the common ones that I'll run into is when we look at 24. Students will say, oh, 12 times 2 is 24, and I agree that those two numbers are factors, or they multiply to 24. But 12 and 2 are not perfect squares. One of those numbers that you break this up into needs to be a perfect square. So we can do 4 and 6. The square root of 4 is 2, and the square root of 6 cannot be broken down, and that is our answer. Lastly, this problem. We're going to multiply 2 and 3. You can't multiply 2 and 10 because that's like cross-contamination. You can't mix your numbers underneath the radical symbol and the numbers outside the radical symbol just at face value. You know, we can maybe do some manipulation with these, but we can't just say, oh, 2 times 10 is 20, 3 times 15 is 45. We can only multiply the two numbers on the outside and the two numbers on the inside. And then we got to think, what is the biggest perfect square I could divide 150 by? And that would be 25. So 25 times 6. This still stays here. The square root of 25 is 5. So it's going to be 6 times 5 times the square root of 6. 6 times 5 is 30. And the square root of 6 stays alone. Stays there. We can't do anything with that. So that is our simplified radical. So I want you to pause the video real quick and try these two. And when you're done, unpause it and see what you get. All right, so here are the answers. Square root of 300 should have been pretty easy to break up into 103, and the square root of 100 is 10. For number 2, when you multiplied 8 and 28, you got 224, and that can be broken up into 16 and 14. You cannot take the square root of 14 or break 14 up. So that stays the same, but the square root of 16 is 4. Now let's look at the next page right here. And this is the quotient property. The quotient property says that if I have a fraction in a square root, I can break this up into two separate square roots. And this can be useful if your denominator is a perfect square, but the numerator isn't. So in this example right here, we can write this as the square root of 2 over the square root of 25, which is equal to the square root of 2 over 5, because the square root of 25 is 5. So we have gotten rid of the square root in the denominator. So now this is simplified. This is proper math because we do not have the square root in that denominator. So let's look at these real quick. The square root of 100 is 10, and the square root of 169 is 13. We can't simplify that fraction any further, so that's our final answer. Square root of 11 over the square root of 144. Square root of 11, and then the square root of 144 is 12. We can't simplify the square root of 11, so that just stays like that. And we're simplified. That problem is all done. Over here, we're going to have the square root of 5 over the square root of 49. The square root of 49 is 7. That's simplified, and we're done. This one, the square root of 15 over the square root of 4, which is 2. We can't simplify the square root of 15 into any perfect square factors, so we are done. So you see that if the denominator is a perfect square, it's really easy to deal with, and we can get the problem solved quicker. But what if you cannot do that? What if I have the square root of 17 in the denominator? How do we handle that? Well, there's a process called rationalizing the denominator. And what that does, it eliminates a radical, and in this case it's a square root, but it can work for any radical, from the denominator. That's called rationalizing the denominator. So there are 3 situations that we could have in the denominator. We could just have a normal radical. And when you have just a normal radical, the square root of 11, the square root of 13 in the denominator, you just multiply by that number, by that same exact thing. So why does this work? It works because the square root of b times the square root of b is the square root of b squared, and these cancel off, and you're just left with b, or whatever number that is. Now, it is important that you have to multiply the numerator and denominator by that, because that's just another form of writing 1. Whoops. However, you then get rid of the radical in the denominator. What if you had a plus a radical in the denominator? What you would need to do is multiply by what is called the conjugate. The conjugate is the exact same thing, except instead of a plus, it'd be a minus. So we would multiply the numerator and the denominator by a minus the square root of b. And the reason for that is because when you FOIL this out, your middle terms will cancel. It's a difference of 2 squares. So look what happens if we do, this is what we were starting with, and we multiply that by a minus the square root of b. When we FOIL this, we get a squared, we get negative a times the square root of b, we get positive a times the square root of b, and then we get negative square root of b squared, which we know that the square root of b squared is just b. And then these would cancel out, so it actually would simplify to a squared minus b. No more radicals. The last situation we could have is if we started with a minus a square root. Then we multiply by the conjugate, which in that case would be a plus the square root of b. The conjugate is always the same values, the same terms, but you're changing that sign in the middle. And again, the reason you do that is because you do not want to get a b term when you multiply. And it would work the same way. A minus the square root of b times a plus the square root of b. When you multiply these two things, we get a squared minus a times the square root of b plus a times the square root of b minus the square root of b squared. And like we said, we already have that. And it will simplify to, these go away, a squared minus b. So that is why we want to rationalize the denominator. It gets rid of our radical or square root in the denominator, and it allows us to have proper math. And we have that, this is called the conjugate. The expressions a plus the square root of b or a minus the square root of b are called conjugates, because the product is always a whole number. You don't have to worry about any radicals. So here, we're going to simplify these expressions. Now, let's make this two separate radicals. We can't have a radical in the denominator, so we need to multiply the top and bottom by the square root of 15. So now what happens is on the top, we have the square root of 2 times the square root of 15, which is the square root of 30. On the bottom, we have the square root of 15 times the square root of 15, which just equals 15, because they cancel each other out. Now, you may think that we are done, but the last thing you need to check is look at the numerator and say, can we simplify the square root of 30? The square root of 30 cannot be broken up or factored into two numbers where one of those numbers is a perfect square. So that means this is my final answer. Now, if the square root on the top could be broken down, you would need to do that. Now, letter B, in the denominator, we have 5 minus 3 times the square root of 2. So that means we have to multiply the top and bottom by 5 plus the square root of 3 over 2. Because that is the conjugate. On top, we distribute the 4, so we will get 20 plus 12 times the square root of 2, which we can't do anything with right now, so I'm not going to try to do any more math on the numerator. On the denominator, 5, we have to FOIL this. 5 times 5 is 25. Then we get plus 15 times the square root of 2 minus 15 times the square root of 2. And then when we multiply the last terms, we get negative 9 times the square root of 4. Now, I'm just writing this all out so you can kind of see why we can do some shortcuts later on. So the top is still going to be 20 plus 12 times the square root of 2. The bottom now, 25. These two are going to cancel because they're the same thing, just one's positive, one's negative. Now, negative 9 times the square root of 4, the square root of 4 is 2. So 9 times 2 is 18. So then we will have 20 plus 12 times the square root of 2 over 25 minus 18. That will give you 7. And then we need to see, can we simplify that any further? And we cannot simplify this any further. That is going to be our answer. Right, for this problem, we're going to multiply the top and bottom by the conjugate of the bottom. So I know that we have 3 plus the square root of 7 on top, but we're concerned about the bottom, so we're going to multiply both sides, or the top and bottom, by 2 minus the square root of 10. And I'm going to put parentheses around these things just to make life a little bit easier. So when we multiply this out or FOIL the top is going to look pretty ugly. So 3 times 2 is 6. 3 times negative square root of 10 is negative 3 times the square root of 10. 7 times the square root of 7 times 2 is 2 times the square root of 7. And then lastly, square root of 7 times the square root of negative square root of 10 is negative square root of 70. The top looks ugly right now. We'll come back to it in a minute. Now the bottom. You could do the shortcut or a shortcut on the bottom. If we look back here, when we multiplied the inner terms and the outside terms, we got these two things right here that canceled off from each other. So what we could do over here as a shortcut is to multiply just the first and the last terms, because we know the other ones are going to cancel away from each other. So the first terms we get 4, and the last terms we get negative square root of 100. Now on the top, that is going to be a giant mess up there, and that's okay. we're going to have 6 minus 3 times the square root of 10 plus 2 times the square root of 7 minus the square root of 70 all over 4 minus 10. You might say, oh, can we combine those things on the top? And you can't actually. You can't combine those terms, so it's just going to stay like that. So here we go on the top. And then on the bottom, we get -6. So this would be our final answer. Yes, it looks ugly, but it is simplified and we cannot combine anything further. All right, down here, I want you to try these two. They're not as complicated as this last one we did in letter C or even letter B. So go ahead, pause the video, try them, and then once you're done, check the answer and see if we got the same thing. Okay, for the pair, I'm sure that one went pretty well. Multiply the top and bottom by the square root of 8. You could have simplified the top first and said, okay, that's going to be 3 over the square root of 8, and then multiply the top and bottom by the square root of 8 to get your answer. Either way would have worked. Now, this one right here, maybe you got this answer. -42 minus 6 times the square root of 5 over 44. If you got this far, that's awesome. We just got to go one more step. These three numbers, it doesn't matter what's inside the square root, but those three numbers are all divisible by 2. So we can divide that out. We can simplify the fraction. So if I divide everything by 2, I will get -21 minus 3 times the square root of 5 over 22. This is the truly simplified answer. Rationalizing the denominator is a process. It takes some time, but it does make life a lot easier when we work with these expressions later on. So if you need to review this, please do so. But thank you for watching. Make sure to like and subscribe.